This afternoon's topic is our stealth systems, our Gen II tanks, our Phantom systems. It's an area where, honestly, this one's all about science. And it's one of the reasons you've seen us progress in tank in so many respects over the last several years. And it's, they call us the aftermarket for a reason. And this level hits us in two ways. Obviously the OEs, the last OE went in tank in 1986, but maybe even more important to us is how the fuel blenders, the refiners, responded to that. If you're a fuel blender and you're responsible for, making gas for Marathon or Quick Trip or, somebody like that, you don't really give any consideration to external inline fuel pumps. And you guys know, you've all heard it 100 times from us, that when you put fuel under vacuum, you drop the boiling point. So when I was a kid, vapor lock used to happen under the hood. You got some ice out of your beverage cooler and, put it on that Carter AFB or that Thermoquad, that Quadrajet, whatever you had. Now that we're adults, it always happens at the back of the car. And what really happens is because the gas is so unfriendly in a negative pressure environment, in a vacuum environment, creates suction side cavitation, or basically sucks itself into vapor. And you get that airlock on the suction side of the pump, and you've seen it. Anybody that's done Power Week has seen it. Two things are pretty consistent on during that week, and that is that their power tour, I should say. That is, the cars are alongside of the road for one of two reasons: either overheating, or the fuel or the fuel system has put enough heat in the fuel that it's sucked itself into vapor, and they have vapor lock, typically at the back of the car. So. That being said, our engineering team has put an awful lot of effort into in-tank solutions. That's where stealth comes from. Phantom is, part of that family. Gen II is the latest in our line of tanks that incorporate now both Phantom and stealth technology. So, if you're familiar with our Gen I tanks, I'm gonna explain in a little bit of detail why we went to Gen II. First and foremost, by utilizing the OE outlet location, we're trying to take full advantage of the real estate that the OE had in that tank, whether there's a Tri-5 Chevrolet or later Model G body, Mopar. We even got some Mopar tanks now, but on all those tanks, there's some amount of real estate. Our engineering team wishes there was more, but in that real estate, you find the terminals for a fuel level sending unit. You find the outlet, you find the return, located all different parts of the tank, all different diameters, some more challenging than others. But as you look at that slide, you kind of get an idea of how we're in that situation. That Mustang tank, we're coming out of the front of the tank. You can see also that we still install the pump and the fuel level sending unit from the top. You can also see how we use our Phantom baffle and bucket. Keep in mind, we have almost 60 Gen II tanks, or actually more than that if you count both the 200 and the 340. But that being said, in these tanks, there's no provision for an in-tank fuel pump. So we have patent protection on the yellow and black components. You see the Phantom technology. And we're able to use that. We have patent protection so that, we can go ahead and spend additional dollars developing R&D'ing other tanks, which we weren't able to do before. But also what I want you to keep in mind is that gallon and a half bucket, our goal is to just keep enough fuel in there to where the inlet of the pump is always covered. But also if you imagine that bucket being 6 inches tall, when it's full, and there are ways to do that with our bladder baffles and things like that. When that's full, you literally have 6 inches of fuel pushing down on the inlet of the fuel pump. And we can make that happen even if there's only an inch of fuel in the tank. And I think that's the most important part. We'll touch on that near the end here. But what I want you to imagine is that bucket full or halfway full and at low fuel levels. That's where this technology will really shine. If the tank's completely full, you can stuff the pump in there with a sock on it and get away with a lot of things, but that's not the reality. The tank is only full until you start the car, or after you've filled up. It's only full until you start the car. You start depleting the fuel immediately. I know that's obvious, but that's kind of where this whole conversation starts. So once you get down to that half tank level and below that, that's where the technology that Aeromotive is able to incorporate really starts to shine. So if your monitor's like mine, you can see in the very, very back of the picture, you can see the float. So we use a float type fuel level sending unit. That's relocated from the factory side. But this picture gives you a good idea how we're able to put the pump, fuel level sending unit, all the wiring, all the plumbing, how it's kind of all packaged inside there. I say that because our customer doesn't see that. Keep in mind, our tanks come fully assembled. We're pretty unique in that regard. Not everybody does that. So our tanks come fully assembled, so the consumer's not in a position where they're trying to figure out how this all fits together. And the fuel level sending units in particular are pretty challenging. You'll notice the hose there. It's OE style hose, so it's not going to crimp or kink or something like that. High quality wiring. I like the weather pack style terminals we use on the 340s. The other thing you'll see is this little orange duck bill in there. That's the return side, and that's that valve is how we're able to return fuel into that bucket and not create kind of an aerated mess in there and then pick that air up again. That duck bill acts like the iris on your eye. It opens and closes depending on the amount of return fuel. So at idle, it's open more. At real high demand, it closes off so that we're not getting that hot aerated fuel directly at the inlet of the fuel pump. The reason I mention that piece, ideally, we would not return into that same place. But if we're in these kinds of systems, you have to make that work. If we return into that, far right corner at the end of the picture, we're not going to have enough fuel in that bucket to make the car perform during dynamic driving, during braking, during cornering, during acceleration. That valve is really underappreciated, but a really important part of these systems. So, thing I want you to take away from that, this is all about hot fuel handling, what we can do with pump gas when we're actually using the car, actually enjoying the car. These are pump gas driven solutions, and you can take full advantage of E85 and everything else, but let's face it, pump gas gets worse every day. And it doesn't matter if you live in California or Ohio or Iowa like Jake. It's bad everywhere we go. It's just worse in some other places. The other advantage of going in that OE location, because there is some amount of clearance, there is some amount of real estate, is we eliminated one of the challenges we had on our Gen 1 tanks. And that is on the Gen 1 tank, everything was on the top. So we added a 5/8 or 3/4 inch billet plate on top of the tank that in a lot of applications was up against the trunk floor. We would ship pieces of real high density foam, create 3 points contact. The challenge that presented was once the installer would put the hoses on, put the wiring on, wrestle the tank into place, if they ever smelled fuel or saw some vapor on the floor, a lot of times they would think they had a leak, and one of those hoses that dropped the tank, nope, everything was tight, it was good. A lot of times it was just fuel pushing out of the vent. And the other side of fuel that is challenging for us is it expands at a real high rate as well. So if you park the car with a full tank, and almost perfectly full tank, fuel would expand, push out of the vent. You see the residue on the floor the next day after it heat soaks for a little while, or an hour later, 2 hours later, whatever it was. So by moving to this OE location, generally there's clearance in there where if you have a concern about a leak or a loose wire or something like that, you can check it there. So really important just to note how we were able to go back and utilize what the OEs had done. All these use the OE lock ring, OE gaskets. So if there's ever, replacement issues, that stuff I think is readily available. Also our tanks, instead of being the kind of blotchy galvanized finish, they're kind of an industrial gray, battleship gray, really nice finish. I'm pretty impressed with the quality of the finish on them. As you know, we introduced, a 200 liter per hour and then 340 liter per hour across all the different platforms and vehicle applications. 200 liter per hour starts at $513. I mean, that's a really, really good value for something that will support, 450 forced induction and 600 naturally aspirated, which is, kind of the sweet spot of that whole that whole market. And like I say, we're up to about 60 applications now. We've been really, I think, proactive in most respects, but sometimes by necessity we have to be reactive, just see where the demand's at. I can't tell you how many of those tanks, probably a third of them were added because of interactions like this, where like, hey, do you have a tank that'll fit this or that? And some of the cars are more obvious than others. But if that's something you have, suggestions on, feel free to contact any of us or bring it up here at the end of the meeting. We always think of these tanks too as, LS swaps. Let's face it, that drives a lot of this market. But the same is true for Coyote motors. The later Hemi stuff, Gen 3 Hemi stuff's been really popular. So yeah, a majority of them probably do end up in EFI style swaps, but keep in mind they work well in carbureted applications, and we'll touch on that in just a moment. There's a list of the applications, a little bit more breakdown there. We go back to Tri-5 Chevrolet and our Gen 2, up to later G-Body. The most recent additions have been on the Chrysler side, which we'll dive in here, real hot and heavy. We have one of the Corvette tanks that, because it has an oddball sending unit configuration, it's on the list there. I need to rewrite that list now that I think about it. I forgot about that until I looked at it. But a lot of applications that people don't know. So some of those tanks are we've just added within the last 12 months. So still some stuff there, new stuff there to be had. This is why I was teasing you on the Mopar stuff. Going back to 64 B body up through 76 A body, we have all the Challenger, Charger, Barracuda tanks. What's unique about the Mopar side right now is we have not only the 200 and the 340, but we also have the 525 liter per hour pump, which is basically the OE replacement for all these Hellcat crate motors and junkyard swaps and stuff like that. What I want to mention here to leave with you is if you're looking at one of those Hellcat swaps and you're going to run the factory ECU and fuel pump control, we're ready to go. That's one of the reasons we use that pump, basically a plug and play scenario. Everything else is the same. These do not fall in that same price range. The Mopar Gen 2s still fall at the 513 and then I think 570 roughly. But the Hellcat tanks with 525 don't fall into that same category. They're a bump up, just more expense. Took some different things internally in terms of hose and plumbing, but also the pump's obviously more expensive. So we teased you about the, not just for EFI swaps, going to get into a little bit more detail there, but it's really all about hot fuel handling when you're driving. Our Gen 1 tanks had a dedicated vent. These do not. We've learned a lot about the tanks. What we do is when we're sourcing the tank, we always take the tank that has the most vents. I mean, there's some of them that it's not uncommon to see as many as 3 different hose barbs, nipples off the side of the tank. That's one way we're able to do that without a dedicated vent. Also, obviously most of these cars are using a vented gas cap, which just adds to the vent capacity there. And I don't want to lose sight of this. Certainly how we build cars has changed. I think when I was a young guy, it was just part of the program to have, Pete Jackson gear drive and open headers and, the loudest fuel pump you could find. It just didn't matter. It's all about making noise. The world's changed, in our industry, it's very common for people to ask, how loud or how quiet it is. Well, the Gen 2 tanks are whisper quiet. Key being that turbine style pumping mechanism on the 340 and the 200 that we use, and the 525. So Aeromotive compared to everybody else, we talked about the advantage of the baffle in the bucket. You can see there how it actually functions as a bucket. We have some competitors that just use an OE sock, just the filter sock sitting on the floor of the tank. Well, if you're at a quarter tank or less and you make a hard right-hand turn, where's the fuel going to go? It's going to go to the opposite side of the tank. And if the pump's in the middle, you're going to be starving for fuel there. So we touched on assembly. That billet had, it's typical Aeromotive quality. I mean, it's just really well machined, 6000 series aluminum. We talked about price and made in the USA. And The apex and bladder baffle, we'll touch on that in just a moment. This is something that has evolved with our Gen 2 tanks, I would say, over the last several months. You know, I talked about the carbureted side. Traditionally, we would use or recommend our 13204, 13304 regulators, one of those two, sometimes 13301. With the limited real estate in the top plate on some of these Gen 2 tanks, but I'm going to say all just so that the statement is more inclusive. Brett, our senior tech guy, has kind of been pushing us this direction, and I think we've come around to where we use part number 13220 in these carbureted applications. How it works, we're basically taking two regulators, basically a 13301 and 13205. So the 301 being a bypass style, the 205 being a deadhead. We're using the 301, the bypass style, to hold system pressure there at 14 to 16 PSI typically, and then the deadhead to knock it down to 4, 5, 6, 7 PSI for the carburetor. And if you're looking at the picture, so on your left, that would be the inlet, and then it returns out the bottom of the regulator on the backside. This all goes back to, when we're talking about return lines, we want to make sure that the return line is not a greater restriction than the regulator itself. And that's kind of the scenario that plays out with the limited real estate we have on the top plate on some of these tanks. That being, we can run a -8 return line back, but there's just enough restriction in the top plate that we can't get pressure down as low as we want to. Keep in mind, and this is just a good backyard check in any return style system you do, if you want 7 at the carburetor with the engine running, make sure you can adjust it down to 5 or 6 PSI. That way we know that the return line is not a greater restriction than the regulator itself. If you're EFI with the vacuum hose disconnected, engine running again, and you want 57, make sure you can adjust it down to 54 or 55. Just a good backyard way to ensure that the return line is not a greater restriction than the regulator itself. So back to why we recommend this regulator. We are able to go back then at 14 or 16 PSI and able to push through a -6 AN hose, basically right size the return line, return side of the system by using that greater pressure. And, we've had this on the market for a little while. It's starting to pick up really well. Another place where you might see this regulator used and what it was originally designed for is like a V8 S10 swap, to where when you're using the OE tank, OE in-tank pump, some portion of that OE system may be using the feed line as the return line is pretty common. This regulator works well in those applications as well. Another little tech piece. This has become a pretty common occurrence, this little Corvette filter regulator combo. Real popular piece, inexpensive, probably designed from the factory for like 190 liter per hour pump. And we've learned over time that it will absolutely destroy a 340 hour pump, our 340 liter per hour pump, just because it is so restrictive. You might still see 57, 58 PSI at the rail, but the head pressure on the outlet side of the pump is so high that it creates a real high amperage draw. Pump's just working harder to push through it. Real high amperage draw creates more heat, clearances start to close up, destroys things pretty quickly. The other part of the story too is the OE piece was probably a better piece than what we see in the aftermarket now. I saw one the other day on a well-known website, I think for $38. So if you're buying a fuel filter and regulator for $38, then you probably know what you're getting. But what I want to leave you with is we got to avoid these at all costs. I mean, they just destroy these pumps, and you kind of see a signature failure when these pumps come back, when our 340 comes back through warranty and return. So just too much heat, too restrictive. Wish we would have had this a few years ago. I'm sure some other guys in the company do. This is our little Fox body module, 340 liter per hour pump. Retails for, I think, around $230. Billet top plate, it's our 340. You can see the high dollar hose, good wire, good connector, uses factory lock ring. My joke is that we had to wait till there was enough LS swaps into Fox bodies to where before we actually needed this little module. But great little piece. That's an awful lot of Aeromotive for your money. So our initial 340s started out, they weren't E85 compatible. How you can tell the difference, the third digit was a 1 rather than a 5. This has been a number of years ago now that we switched to make them all E85 compatible. Just want to remind you while I'm telling you about that, that keep in mind that E85 requires 30% more fuel to make the same horsepower as gasoline. So the horsepower ratings don't stay the same. You can see the horsepower ratings there on your screen. 340 applications. This is close we get to a plug and play fuel pump in an OE module. You know, and every time I look at that list, and I've been doing this a long time, there's something on there that I would forget that Aeromotive makes a fuel pump for. But you look at some of the brands, some of the different applications. Engineers have done the best they can to verify that the OE electrical bulkhead is up to, you know, snuff, that the OE return line is large enough that we won't, back to when we were talking about 13220, that there won't be a greater restriction that OE return line, and that the OE baffle, basket, bucket, whatever they have in there is large enough that, you know, a lot of these were probably doubling the fuel capacity by using this pump. So, but don't let that list escape you. There's every now and then I'll stumble across an opportunity to sell somebody one of our 340s based on that application list. It's in our printed catalog. It's also on our website under FAQs. Dive in now a little bit to the Phantom. I'm sorry. Okay, thought I heard somebody there. Into our Phantom line. Phantom line has really grown, kind of carved out its own unique space in the company. If you think of that application guide I just showed you, that's as simple a plug and play as you have. Next above that would be our Gen II tanks, where, you know, basically going to hook up 2 wires, 2 hoses, you know, push the tank up there and you're good to go. The Phantom line still has a place in that it's more universal, or we can't fit the horsepower requirements, just a variety of other reasons. A lot of the Phantom stuff is also available more as complete kits with filter, with regulator. You can see in the picture there, that gives you a good idea what's in the bill of materials. Obviously, a lot of consumers like a big box, you know, single SKU, one-stop shop, and we're trying to provide that here with our Phantom systems as well. You'll see a few in there for returnless pulse width modulation. There's a carbureted kit, different things there. I'll probably need to work with engineering to update that carbureted kit based on the recommendation we made on well, that wouldn't impact Gen II, our Gen II tanks. So Phantom Flex introduced this based on a distributor recommendation. Uses our 450 liter power pump. At first was intended to cover that E85 market as we saw things transition, but as horsepower levels have gone up, and this is compatible with gas. There's if it's compatible with the 85, it's fully compatible with gas. But the difference here being, being that pump, you can see the horsepower ratings down there at the bottom, 800 EFI forced induction. Carbureted Phantom. So this came out of more of the traditional street rod market, to where the enthusiast didn't want to run a return line. So this has an internal bypass, just a little piece of hex stock with a spring and a valve in it, preset at 15 PSI. It does require a deadhead regulator. So you're still going to have a regulator on the front side, but at least we're, running a single line up to the front of the car. If you have an existing Phantom, you can retrofit part number 18702 into that. It's as simple as remove a pipe plug, put a valve in, if that's, where your project is at. Also want to point out, when I say universal, these are just that. I mean, you can install them in any tank. The standard ones from 6 to 11 inches, and there's a little bit of wiggle room on either side of that. We also have extension kits available, and all the Phantoms, you're basically hole saw, 3 1/4 inch hole. You've got a little drill tool here that, if you can see, the newer ones are a injection molded piece, but that registers inside the hole. You don't have to measure and mark the holes. You actually just drill through the tool. Then it serves as a funnel. Once you cut the yellow foam to height, which is an inch over tank depth, and that's just to hold that black bucket in place. You scrunch that up, you push it down through that tool that's a funnel, and then that tool goes in the top of your toolbox. So we told you about Carbureted Phantom, EFI Phantom, same basic principle, preset at 60 PSI, perfect for LSs and Coyotes, stuff like that. And the valve 18703 you can retrofit. Like I'm running a little short on time there, Jake. I'll hustle it up here a little bit. Dual
Awesome.
Phantom has really found a home in two different, uniquely or distinctly different markets. First one being forced induction streetcar. You can run these dual 340s either staged or simultaneously. So most of the market, I think, where we find it, they're staged. So in that market, you'd spend all your part throttle cruising on a single 340 and trigger the second one, you know, based on a Hobbs switch, pressure switch, boost, whatever you want. Just, you know, the options there are almost limitless. That way you're doing all your part throttle cruising on a single pump, back to where we started about trying to keep the fuel cool, reduce the cycle rate. Plays well in all those spaces. Then in the off-road market, how they'll use it is they'll just create a redundant system. So you'll have a, you know, pump A and then a pump B, like NASCAR does with ignition. So two distinctly different markets that this product fits into really, really well. Triple Phantom, this is the lunatic fringe. I had for years probably said that we would never have a triple pump option, and here we are with triple 450s. And this is really geared towards that E85 market. You look at the horsepower ratings there, 1,650 on EFI forced induction 85. You know, that's a lot of horsepower. Keep in mind, we're looking at some extra work on the electrical side here. And the pumps are staged, so you have a primary pump, and then pumps 2 and 3 come on simultaneously. But read the instructions closely just to make sure you meet the electrical requirements for this piece. GM truck, we talked a lot about this in our late model session yesterday. You'll see there all the information's right in front of you. What I want to leave with you, these are Phantom style systems. Use the yellow baffle and bucket. Engineering is just finishing up the fuel level sending unit brackets for these modules. That's something we've been waiting on for a little while. So if you need one of those brackets, get a hold of Aeromotive Tech, and we can get that sorted out here soon. Apex, this is where this stuff's getting really cool. This is the Aeromotive version of a jet siphon. You will find jet siphons used in the OEs and their saddlebag tanks in just about every performance car now. In the aftermarket world, whether it's off-road or road course, you know, some off-road cells are 60 or 80 gallons. We can use this jet siphon to move a gallon a minute through this self-wetting jet siphon. The jet siphon is actually the little black rectangle you see there. It has a little jetted orifice inside of it. Works off the pressure side of the pump. So we're going to lose some system capacity because it works off the pressure side. About 15% is what we're going to lose. I'll show you that in just a moment. The hose itself locates with a magnet. So if you have a poly tank or an aluminum tank, there's a second magnet in the kit. So basically you use one magnet to locate the other. Can epoxy the exterior magnet if you want. Really slick little system how it works. And I'm going to show you a video here just to show how it overfills this bucket. The cool thing is you can pull this hose out of the fuel while it's running and it won't lose prime. And we've actually had guys do that at the show just to kind of prove the concept. But at any rate, what I want you to notice is up here at the top of the bucket, we're overfilling that bucket. See, the fuel's down to maybe inch and a quarter, but we've got, 6+ inches of fuel feeding the inlet of that pump at all times. This is really going to be neat technology. We're finding uses for this every day. Found a new use for it in agriculture here just several months ago. You will see us using this technology more and more in a lot of markets. The other way we keep that bucket full is these little bladder baffles that snap into the bottom. If you're familiar with the Phantom, there's 1/2-inch holes around the bottom. So you snap these in, they're just a one-way check valve. Really neat little piece. Something I want to emphasize on the Apex Phantom units is we've been finding more use for these in pulse width modulated and in direct injected engine swaps as a total solution for how to feed either that DI pump or to just create a happier system in that PWM space. OE tanks and stuff like that are doing those swaps where they're using an OE, ECU, and fuel pump driver. Starting to put together kind of a tech bulletin on that, go into more detail, but keep these in mind when we're looking at a DI or pulse width modulated returnless system, obviously. I mentioned we give up about 15% system capacity. So when you look at the Phantom 450, you start to see numbers that, that more resemble the 340 and the 340 on down. So you can get the Apex either on with the Apex installed, or you can buy the jet siphon as part number 18706 as a standalone unit you can retrofit. They will fit on a Phantom, on a dual Phantom. They will not fit on the trifecta. Just not enough room under the house, those 3 pumps, to get the valve in there. So there's my contact info. If you have any questions, want to follow up offline, there's my email address, my extension. So feel free. Jake, you got any questions for me while we look at my notes?
Yeah, we don't have any questions rolling in yet, but why would we use a dual or triple Phantom versus one of our A1000s or Eliminators? What would be the, obviously horsepower is very similar in those aspects,
Sure.
but there's got to be a reason why we use a Phantom versus the brushless pumps.
Absolutely. So how I would equate that, I'm going to expand your question a little bit. That dual Phantom, obviously, if we're staging the pumps, that means running one pump as a primary, one as a secondary or an auxiliary. Our cycle rate is going to be dictated by that single pump rather than both of them run simultaneously. So amperage draw is going to be cut in half. Cycle rate's going to be cut in half. From your experience that if you can cut cycle rate and amperage draw in half, fuel is going to be much cooler. You also know from the 30 minutes ago that if fuel's hot, when you put it under a vacuum, you tend to suck it into vapor, creating vapor lock. So those two things come into play. So that takes me to the next level. We almost end up the decision not being a dual Phantom or an 11101 conventional A1000 brush style A1000. Then our choice becomes, okay, do we use a brushless A1000 with true variable speed control or a dual Phantom? So, and the fact that true variable speed A1000 has only been on the market for a little bit more than a month now, I guess. I think just finally released in February. That'll become kind of the next decision down the road, and then you're kind of looking at the architecture of the two. That dual Phantom comes with the baffle and basket. It's more of a complete system. Whereas if you had an in-tank A1000 true variable speed brushless, then you're building a collector box. You have some more things going on there. But great question, and it's something down the road it'll be interesting to see how it plays out, because the true variable speed technology gives us a way to change that cycle rate, maybe even create a curve. Whereas the dual Phantom, you're going to be pump 1 and then pump 2. It's going to be the step up, which you could also do with the true variable speed, but it's nice to have options.
Yeah. Joe asked about a 70 El Camino. Have you heard anything about Gen 2 tanks for that?
That's I'm glad you bring that up, because I think that's the 4th or 5th request. So I'll try to move that to the next to the top of the priority list, if you will, on our next big tank order. And I think there's more El Camino demand for El Camino out there, more than we think. I'm probably the biggest flag waver because we've got an El Camino out in the garage here a little bit later than that. But from 64, 65 on up, that's been the challenge so far. Is there's a number of tanks up through mid 70s. I don't remember exactly how many. So it hasn't grouped really tightly. I think the first requests I had were 64, 65, and then this 70, I think. Well, you know how it is. There's 2 or 3 year groups there. So I don't remember if the 70 is the same as the 68, 69. I don't think it is. But at any rate, thank you for that. I'll add that onto the list and see if I can push a little harder to get that El Camino tank in there.
Yeah, and Dar's asking about Tri-5 stuff. Obviously, we have them in the Gen 1s. Any thoughts about Gen 2s?
Yeah, I think isn't there a Gen 2 Tri-5?
Yeah, and Buick Skylark is what he was thinking too.
Yeah. So I started working on this a little bit last week, and Brett and I have both. We missed some of the BOP crossovers. Matter of fact, even the Firebird, for whatever reason, for a while, Firebird dropped off of our Camaro listing on first gen Camaro. So That happens once in a while. So generally in the catalog, you will find the most generic description, I guess. On the price sheet, for those of you that are distributors and reps, on the price sheet is probably the first place you will see an expanded listing where, particularly on the GM side and to some extent the Mopar side, to where to where we get all the kind of the unique applications. So on DAR's end, that Tri-5 Chevy is $18,199 and $18,499. $18,499 for the 340, $18,199 for the 200 liter per hour.
Okay. He's also asking about like 32 Ford tanks and different things like that. I didn't understand his 32, 33, 24.
Yeah, so that tank we had as a Gen 1, the architecture, so it was 33 and 34 being one part number, 32 being another one. The architecture just does not allow for the Gen 2 technology. Haven't lost sight of that. You guys know I've got a pretty soft spot for street rods as well. So I'll revisit that down the road. Don't know the current status of Gen 1, but I believe we can still build that tank in a Gen 1 configuration.
Okay. Mr. Bovey wants to know about the 67, 68 Cougar. He thinks the same listing as the Mustang.
Tell you what, Joe, if you think of it, shoot me an email on that. And I've got the electronic catalog with me, but it's a pain to access because it's, I think, 70 some pages. So if you shoot me an email on that, but I think you are right on that. But it's been a while since I had to think about Cougar. Shoot me an email though, and I'll dig into that for you, sir.
Another one that was on there that's a good question. The lifespan of the foam.
Oh, great question. So I'm going to answer that in a couple of ways. We, as a company, do soak tests 24/7, 365 days a year, and they're just ongoing. And so it might be anything from water to E10 to E85 to diesel to methanol, you name it. And we're talking all the soft parts. I mean, it'll be diaphragms, it'll be the baffle in the bucket, different things like that. Two stories here, kind of anecdotal. The only guy that I personally know that had issues with the yellow foam was a Mustang guy in somewhere near Atlanta, Georgia, and had got the car running. And I think he said with the original tank of gas from, when he did this would have been a Gen 1 tank or early Gen 2 tank. Got the car running, drove it to body shop prison. And 3 or 4 years later, finally got the car back and had almost instant system failure. And when he pulled his pressure side filter, it was primarily full of Bondo dust. Apparently, the entire time the car was in there, the gas cap had been left off, and the tank was just full of Bondo dust. But he was able to show me pictures to where, if you can imagine a water line, in this case being the fuel line, of where there was, the foam had ended up. So that was the only one I personally know of with foam failure, but there was all kinds of things at play, really, really old fuel, whatever the chemical reaction of the Bondo dust and the ethanol and whatever additive packages. That's something I didn't talk about on the fuel side too. It's not just the ethanol component, the additive packages that the fuel blenders put in there change frequently. And I don't know that anybody can stay out in front of them. Now, the only time the black bucket has really come into play is somebody that had a really old one and they were trying to snap the little bladder baffles in. It will harden up to the extent to where, if you're snapping those in, you may not get the fit you want. That's why I think on our service parts side, we've been able to figure out a solution for that. But the tests are ongoing. We use the same foam in diesel as we use in E85 as we use in gas, if that gives you any comfort. So to this point, we haven't had to put replace after 5 years, replace after 10 years, tech bulletin out there. And obviously there's Phantoms that are way older than 5 years out there. So I have a pretty good feeling that to date, something will change down the road, but to date, the lifespan on those, on the baffle and basket is long.
Well, talking about additives, anything that'll destroy the baffles, or any fuel additives that'll destroy even the foam that you're aware of?
That's a good question. I'm sure there's something out there. I might have to reach out to Brett, our senior tech guy, on that, and ask if he's ran across any. I know guys that use seafoam and stuff like that religiously, or Sta-Bil, stuff like that. I don't know for sure, but I have a pretty good feeling about that. I'll reach out to engineering and then Brett as well, see if we have any either engineering suggestions or more anecdotal stuff off the tech line. But great question. That might be a good tech bulletin down the road too.
Yeah. Joe has a question here also. What would you recommend for an '04 Acura RSX with a K20 with a turbo pushing 650 to 700 horsepower? You think the 340 in tank would cut it, or do you think something here?
What color's the interior? We left a detail out on that one. What's base? So you guys know how to do this, right? You got to look at see where base pressure's at, and then how much boost we're making. So you take those two. I don't know what those numbers are, but let me just talk through it in general scenarios, and then we get more specific. But so what we want to do, if you have a catalog handy, is go to flow curves on page 6, and once we know that total pressure, base pressure and boost pressure added up, then we can go, follow the flow curve, figure out where we end up at that pressure in terms of pounds per hour. And then the next question we're going to ask is, okay, we know that, what's the brake specific fuel consumption? So in that case, being forced induction, we try to be conservative. We're probably going to end up at like 0.65, 0.70 to be safe. Sometimes in these applications, you want to ask, does it have an intercooler? Intercooler brake specific tends to be lower. Without an intercooler, it tends to be higher. So really what we're driving, and also if it's on E85, then don't forget we got to add 30% more on top of that. So those are the questions we're going to ask in that scenario. And then we're going to go back and let the flow curve do some of the work just to figure out how much we can support. So throw out again the specific numbers on that. I'll see if we can even get close.
Okay.
What was our base pressure?
We don't have that.
Okay.
But we're 650 to 700 horsepower.
And is that a flywheel number or a wheel number?
Okay. Yeah, if we can get a little more information, we'll get that answered.
Yeah. And that's a good way to, let me kind of segue into this. It's almost that scenario where if you're working the counter at a retail store and a guy walks in and says he wants a 500 horsepower fuel pump, the world's not that simple, so what we want to determine is, okay, is it EFI or carbureted? Because obviously EFI is going to be at a higher system pressure than carbureted. Why does system pressure matter? Well, as pressure goes up, the pump slows down, which reduces flow. Let me try saying that again. As pressure goes up, the pump slows down. As the pump slows down, there's less flow. That's why fuel curves actually have a curve and aren't just straight across the line. If they're straight across the line, we could have a 500 horsepower fuel pump, whether it was carbureted or EFI or forced induction. That's not the reality. So as pressure goes up, flow falls off. That's why you'll see at higher pressure that, there's always a curve, a downhill slope, if you will, at the higher pressures. So we want to know that. Then back on fuel, obviously, if it takes 30% more E85. So, if he's a 500 horsepower flywheel gas guy, then we got to add 30% to that in terms of horsepower capacity if he's going to run the car on E85 rather than gas. Forced induction pressures tend to be higher than naturally aspirated. So that's why you'll see there's a matrix. I'm going to show this. I kind of forgot I was on camera. Let me show you this little matrix and explain why we do it.
Yeah, and so he's talking flywheel horsepower. It's EFI standard gas.
So here's our Stealth 340. So at E85, Jake, can you see that all right?
Not really.
Probably not clear. Okay, I'll kind of describe the matrix then. So you'll notice two things. The E85 ratings are always lower than gas, back to that 30%. The naturally aspirated ratings are always higher than forced induction, because if you're NA in the same combination, if you're not under boost, it's going to be at a lower pressure. And that's how that matrix kind of plays out. So in your scenario, did you say it was flywheel or rear wheel?
Yep, he said flywheel.
Flywheel. Okay. Yeah, you're just, I mean, that 700 horsepower number is not going to leave you much headroom, assuming it's a 60 psi base and let's just say 15 pounds of boost. Let's see what the flow curve says. The other variable I didn't throw in there is voltage. If your pump's only seeing 12 volts as opposed to 13.5, there's, let's say, a 15-20% difference there, just depending on where we're at actually on voltage. So at 12 volts, we're maybe 375 pounds per hour. At 13 and a half, we're 4.25. So I don't want to grab my phone right now, but if we're 0.65, that gives you an idea of how close that is. We have some fudge factors built in on on our ratings, and actually there's a couple different ways on that we can show you on our tech bulletins how to do it. Also, if you have access to aeromotiveinc.com, go there and look at our pump finder and plug in your values there. Jake, do we want to go there while we're online?
Yeah, you might as well, real quick.
Okay.
I got a couple other questions here too.
Go ahead, and I'll play along while I'm going to.
Yeah, this will be a quick and easy one. I haven't heard anything yet, but JKU stuff, have you heard anything on your end, or are you allowed to talk about that at all yet?
Yeah, we've been working on. So there's, I think there was 17 JTs, which is the Gladiator, at the SEMA show that had some variation on Aeromotive system. A lot of them were using dual Phantom or Phantom Flex. In addition to the OE module, just as you can imagine, all the obvious reasons. I have, even as late as last night, working with Genrite. Genrite uses a lot of Phantoms and actually has an adapter plate for JT, JL, and JK to use their tanks. Their aluminum tanks, I think, are real popular when guys are moving the tank to the back with suspension swaps or looking for extra capacity. Tony actually used a dual Phantom on Terremoto to make a finish with a street-driven JK at King of the Hammers this year, which I thought was a pretty outstanding accomplishment. So can you guys see what I'm doing here online with the pump selector? Okay. And was that on gas? Did I hear right?
Yes.
Okay. And tank. And we said what, 600 flywheel?
650 to 700 flywheel.
Okay, I'm going to go to the high side. I'm conservative, you know that. So this is, I was hoping this wasn't going to be my Elon Musk moment where I throw the ball at the truck and it goes through. So a couple options there. We're not vehicle specific in this regard, but see the Phantom 340. So we pulled enough data to to look at the flywheel horsepower rating there, and it brought back that Phantom 340 answer. Either 6-gallon cell, 20-gallon cell. Obviously, there should be a 15 in there as well. Want to scroll down just so you know what's coming in the future. This is still in early stages, but we want to you got a lot of options on that. So if we select one of these, we'll select that Phantom 340. Then at some point in time, you'll see the power planner there, which is a nice feature. Kind of gives you a regulator, filter, plumbing recommendations. Got a little video going on here with Apex. Then we want to get these related products to where they're more representative of what we might find up there in the power planner. So got some work to do there, but my goal would be regulators, filters, stuff like that. So that's kind of where we're going on that page. So back on, what was that, an Audi?
Acura RSX.
Acura. Okay. Let's see. I didn't look for it in our app guide. So 11541 covers, or RSX covers 2002 up 11542. So, so that would give me a pretty good feeling that that's a pretty viable product recommendation.
Yeah. So 2002, the current for that RSX 11542. There's the part number there. Plug and play. Just the Stealth 340. Richie's got a good question also for you.
Hey, Richie. Hey, Richie,
There
I've
are,
got a light bulb over here that needs to be changed. It's up in a ceiling fan. You think you can stop by later and help me?
I don't know if he'll even be on after that. Oh, he
Yeah.
said sure. um,
Anyway, I'm sorry. I didn't mean to interrupt.
the benefit of like a Gen 2 tank or a Phantom system over a surge tank that's offered by the people that are switching it from the carbureted to the EFI,
Oh,
those conversion companies.
so the challenge we have, and there's been products on the market for a while. Phytech has their command center. Edelbrock has a piece. I think Edelbrock's on their third or fourth version. They've worked really hard on that, and and without even being brand or manufacturer specific, the biggest challenge you have, and Aeromotive actually worked on a piece like that. Rich, you might even remember the year. We had a old yellow Chevrolet, block mounted mechanical pump, and I mean, I'm talking 20 years ago, I guess. And
Oh, did you fall off, Kyle?
is you end up with, can you hear me?
Yep, I must
Okay.
have either lost you or you must have lost us.
Okay. The challenge you have in those scenarios is even if it's a gallon container, by the time you stuff a pump and a filter and everything else in there, you give up some of that capacity. And the cycle rate, remember earlier when we were talking about cycle rate in our Gen 2 tanks, the cycle rate becomes so high that the fuel is just extremely hot, extremely hot. And to Aeromotive's credit, we've worked with some of the other manufacturers trying to help find a solution. Some of them are trying to source parts from us, just a variety of things, just business to business stuff. At the end of the day, you've got that container under the hood, the hottest part of the car. It's sealed by the hood. There's no airflow across it. It's inches away from the exhaust. So you've got all these heat sources. You have this very small, relatively small container with a pump inside of it, just beating the fuel to death, the hot fuel to death. It's just not a viable solution with the fuel we have today. So, uh, you know, marketing is what marketing is, but at the end of the day, the systems just don't work as intended. And, we've struggled over the years. How do you take a guy who's, he's of my generation or older, and he understands that block mounted mechanical fuel pump, and he just doesn't want to run a return line a lot of times. But we've worked hard to educate those guys to understand why a Gen 2 tank with a return line, all the advantages are there. And a lot of that goes back to how we build the cars. But even that, I can't remember if it was an Impala or Biscayne, but even that big old thing with all that room under hood, there was just no way to keep the cycle rate and the fuel cool enough to make it a viable product. And honestly, I don't know that, based on NASCAR experience, I like that fuel container up in that right front corner anyway. So that's just, it is what it is. There's way better solutions, more practical solutions. And, the Gen 2 tank selling for $513 by the time if you add a filter and a regulator in there, a little extra plumbing, I think your dollar's ahead and your hot rod's going to work way better.
I completely forgot to ask this question earlier, but and we covered it yesterday, but replacing that filter after the first 100 miles.
Perfect. I missed that as well. So thank you. So yeah, this is something I think, we all learn from experience. So when I'm helping a customer, select components for a system, whether it's a cell or a tank and, plumbing, things like that, the thing that's become more and more apparent is recommend that 12601 replacement element. That's the 10 micron cellulose element that'll fit all the different filter bodies, starting with 12301, but going into our, 347, I think it is, that now we have male-ended filters, 6, 8, and 10 male-ended filters. So a lot of filter options, but sell them on that 12601. I think it retails for $16, and encourage them to, when it's convenient. There's no magic in 100 miles any more than 110 miles or 200 miles. It'll just depend on how they drive the car, but we want them to have that element ready so that the first time they service it, if they need to replace it, if they find some stuff in there, and I guarantee you they will, because gas is a great solvent, and it doesn't matter how careful you are building those hoses or how careful we are building the tank, there's going to be mold release in the hoses and different things like that. And I'm not talking, metallic stuff. Most of the time it's just the grit and grime and everything from assembling product. I'll probably find a shop rag, or I usually find a shop rag in my oil filter after engine assembly. So, and I think I'm clean until I find half a shop rag in there and the other half in the washer and dryer when my wife does my laundry. So try to get them to buy that 12601 on the front side. That way it's sitting there and they aren't going to be paying, freight on a $16 replacement element. Thanks for bringing that up.
Yeah, and what about people that are making metal baskets? What's the advantage of the foam?
The foam, like in our Gen II?
Yeah, so Rich's question was there's some companies offering conversion systems that have metal basket or similar without foam. What's the importance of the foam in the large volume of the Aeromotive basket?
Well, for us, so keep in mind the yellow foam in our Phantom style system, it really just serves as a backbone for that black bucket. I mean, it locates it that way, or that's why we want it to be an inch over tank depth, just so there's some compression on it. So it locates that black bucket, it gives it shape, keeps it round, otherwise that black bucket would be impacted by the fuel flow or the fuel slosh in the tank. That's the primary purpose there. It's not as much anti-slosh, as like you find in a race style or FIA style cell. It doesn't really serve that purpose. I'm sure it slows the fuel down, some, but real goal for us being, to give a backbone to that black bucket. Our early Gen 1 tanks, or our Gen 1 tanks had a metal tray inside them of some type, but there's no perfect solution there. We had gone through a couple iterations on our first Gen Camaro tank, just because that's the way guys use those. I mean, it's so easy to build 1G car now with tires, suspension, brakes, stuff like that we were, using different type of baffling then just to control fuel around the tray. And I'm pretty confident, especially if you can take one of these yellow and black baffle and bucket assemblies, put the bladder valves in there, the one-way check valves, and run that siphon. I think you've got an autocross happy tank that none of the fixed tray guys would be able to compete with at all. So, matter of fact, John Hotchkiss, one of his projects, we just put the bladder baffles in a Gen 2 tank there, and John and his guys run that car really, really hard on autocross, and I think they've been super happy with it.
Awesome. Well, we're out of questions for now, so if there's anything else that you have, Kyle.
No, let me look at my notes here real quick, but that was a good session, guys. I'm glad, really appreciate the questions too. We talked about hot fuel. You brought up some handling or filtering type stuff. Don't lose sight of that. If I was going to leave you with anything today, it all comes back to how we drive our cars too. So I think that apex, whether it's on a DI or pulse width modulation type application, or if it's just in a guy who's going to, hustle his car around the corners really, really hard. I think, a year from now, we'll be talking about apex and in a whole different light. I think once that technology is better understood and more people use it, I think those kinds of solutions are, that's going to be the future of how we use our cars, how we build fuel systems for cars that we truly use, that we really beat on.
Yeah. For the next session, we're mostly going over the Aeromotive website. We're also probably just going to cover everything that little stuff that we might have missed, haven't thought about yet.
Yeah, we can throw that in there and certainly open it up to questions. I think, more of a give and take type format early on. There's, just a handful of things. You've seen the pump finder if you're in this session. There's some ways I like to use the instructions to show, if we have a consumer who's looking to buy pump regulator filter, and then he's like, man, I'd rather have the plumbing and everything else, that one big box solution. We can take them, we can show how I like to use the instructions to get the consumer over the hump, when they're trying to justify the additional dollars of the big box. You guys are familiar with the tech bulletins, but we've updated some stuff there, the FAQs, things like that. That tech help button to me is just a gold mine. Especially if you're dealing with a jobber or something and he's just, he wants to get down on the weeds and something, you can email him that. So we'll go through there a little bit and maybe show you where we've updated a few things, just knowing that, how guys use the website has changed tremendously over the past several years.
Richie was just a minute or two late past this conversation to be introduced to the Wallies behind you, but any speed secrets to winning those?
Richie knows how I race well enough to understand that it's probably more about the left pedal than the right pedal for me. So I don't know why my car can just never run the same dang speed. It speeds all over the place. I don't get it. I go down there, it just loses power and stops. Something weird going on there.
Yeah. All right, man.
So thank you, guys. I really appreciate your time. I know this is a unique time in our shared history together, and appreciate you carving out part of your day to sit down and have some fun with us.